Hi guys, Tackleizer here. I'm back on working on this car battery charger. I was talking about some improvements. I did some testing before starting this video because I didn't want to make a fool of myself. I found a way to test if this actually does something. It obviously does because you know, that's what capacitors do in electronics. I'm putting an output filtering capacitor here, but I wanted, as opposed to previous years when I was much more unexperienced, I prefer to have some kind of actual proof nowadays that something works. So I did some testing. Really cool stuff. I came up with this idea because I don't have kind of off screen there. I don't have an oscilloscope yet, though I want to buy one really soon. One of those cheap, pocket oscilloscopes from AliExpress or something. Obviously, the professional ones are too expensive for me, and really it's not something that I can fully use. I mean, that's something you use for high frequency ranges and professional repairs and stuff like that. I just need to see basically some waveforms and voltage, and that's it. I don't need any specific functions. I definitely don't need such high frequencies. At most within the audio frequency range up to 20 kilohertz. Nothing about that. I don't see why. Maybe some laptop stuff, but I am still thinking if I'm ever going to go into that kind of repairs, it's nothing that I really want to do anyway. One of those pocket oscilloscopes can be very cheap, and I'll get one soon, but I don't have one yet. So what I came up with was I calculated a resistor for the speaker right here. It's an 8 ohm. Is it like, I don't know. Still how to get used with camera orientation and stuff. It's an 8 ohm half watt speaker. I did some math here. Let's try and put this on camera. As you can see, you can see, I came up with a value of 300 ohms for the given power of the speaker, so you don't blow it up. So I put this 332 ohm resistor in series. This is plugged in right now, and I just used my webcam microphone on top of the speaker and just record the sound, and you can get a basic idea of what the waveform is. Let's see, I'm gonna save this as no cap, I think, and just okay, let me check something really quick, because I saved some stuff and I don't exactly know. Oh, these open with dialogues always so messy. If I could just, get a list of programs you recently opened. So this is no capacitor. Why won't I close it? This is a capacitor. Hold on. Yeah. So I have the saved files, but I'm gonna do new ones anyway, so I didn't really need to do that. So the charger is plugged in right now. What the hell is that? Put the camera microphone directly on top of the speaker. Connect the speaker. It has absolutely no importance about what polarity you use, and just hit record. Let's see here. Oh, Yeah, kind of see the screen. That's better. And hit record. Wait, I'm gonna improve the sampling rate. Hold on, this was for a vibration sensor. I'm gonna move it to 48,000. This is no capacitor on, as you can clearly see. This is your sine waveform right here. Okay, I'm not sure why there is such a difference. It seems that there's one high peak, two medium and one low, one high, two medium, one low, and it keeps repeating. But I assume it has something to do with the webcam resonating. You know, it's not a perfect setup. The perfect setup would be a microphone glued to the speaker and whatever, you know. But you get a basic idea. We don't need any kind of precision here, other than seeing that it's a rather loud sine wave. It's pretty loud, as you can see. It's actually well within, well above the zero line. So let me just uncouple this. There's no heating. It can't heat with the values I chose. Let's go back here. I have the capacitor already connected to one of the wires. Let's solder the other wire to the capacitor. That is done. So I'm going to save this as, let's go back here. I'm going to save it as no cap because there's no capacitor. I'm going to go ahead and close this file, hook up the speaker again, be quiet, and record again. You can already see how much lower this is as an intensity. I'm going to save this as well as cap.wav with a capacitor on. Now let's see if I can double open the program. Yes, definitely, that's a good thing. It's a good thing I also have two screens. And then I'm gonna open no cap here and take a look at that. Zoom out a bit. These are the two screens. The right one is without a capacitor. This is with a capacitor. We're gonna read the values too. Bear in mind that this is not. Can I select decibels? Okay, because this is much more intuitive. This is not voltage because it's a microphone input, so you can't really. Well, I assume if you use some kind of those weird software, that doesn't matter. There's no voltage here. But clearly, the same intensity signals look the same. This is clearly much louder, much higher intensity. Not as intensity. Don't get me wrong. It doesn't mean it has a higher voltage. It means that the difference between the peaks is a lot larger than so it's a much more flatter signal. This one on the left with the capacitor. Let's do some zooming in here. Okay, these are some background noises because remember we are using a microphone. Let me get this the highest line here. Can I? That's the one in the picture. It's about 52.5 decibels. This is without minus 52.5. This is with a capacitor. Remember that these are negative values. The closer you get to zero, the louder the signal is. Let's get to this one. with no capacitor, we can see that the signal is above minus 20 decibels. So this thing is what, like 52, and this is more than like 2 times higher than this. And if you bring them, these white lines are the maximum that you can record, and if you see that, you clearly see the difference. Look. This left one, the one on the left, you can barely see the line when it's zoomed out like this, and with this one you can clearly see the sign all the way through. So like this, if I make them almost the same, look at this difference. So that is how much difference a capacitor makes. Now, what this means, I have absolutely no idea if this is worth it for the battery. As far as I know, lead acid batteries, I haven't researched this. I don't want to do any research. I'm just trying to do something for fun, you know. As far as I know, we're talking about devices that work with direct current. These batteries. Let me see if can I see myself? Somewhat, I don't know. As far as I know, these batteries are DC current things, and the chargers should be DC. So I'm not really sure if car batteries are as demanding as, for instance, solar batteries or stuff like that, or for UPSs, more sensitive electronic stuff. But I see no problem in making the signal a lot less wavy. I think this is a good thing. I don't see a battery getting any positive effects from a sine wave, because it doesn't work like that. Batteries work in continuous linear processes, whether you're talking about electricity or chemical stuff happening. There's nothing wavy about them. So I think that modulating a voltage like that 100 times a second, because remember the rectified thing is doubled, because you also get the negative peak on top, so the frequency is 100 Hertz. I don't know, I think it's at least not nice, if not even harmful for the battery. I don't know, I can do a quick search. Let's see, I'm not gonna spend a whole bunch of time on this. Is sine wave good for charging a car battery? I did mean that. I get power inverters. Why do I get inverters? Power, and how long can you charge? Can you charge a battery with AC? So it is fairly common to see lead acid battery charged using rectified AC. As long as the charging current isn't beyond the capability of the battery, it will work, in quotes, if there isn't a serious resistor somewhere. And I don't see anything except for this this amp meter here, which I will measure right now. See what kind of maybe there's some kind of magic going on in there, though I highly doubt it. The only magic that this thing does, it doesn't really work that well. Of course, it's basically a short circuit like any amp meter will be. That shunt resistance in there. there isn't a series resistor somewhere or some primary side limiter, the winding resistance of the transformer could be what's limiting the charging current. The handheld multimeter is sensitive to 60 Hz AC, so here DC reading was likely skewed. The circuit is if there isn't any explicit current limiting protection in the charger, it is possible that the charger can become damaged if subjected to long-term overload. Wall-wart adapters have similar failure models. Usually the transformer goes high impedance. Okay. Well, yeah, not really, no. But as I said, it's, at least not nice to use this. So, also given the fact that they said that you can have problems with the actual charger, I'm actually quite amazed, because I would suspect things going bad with the battery as well. But anyway, it's not okay. So if you went to this trouble to put in a transformer and a rectifying bridge in a box like this and an indicator which you absolutely do not need, because let's be honest, who knows how many people actually know how much current you need, how much charging current, and what the value should be. I don't even know it myself at this point, so it's, for the usual driver, you don't use it. So as long as you've gone to the trouble of putting all these things in, put a damn capacitor, in there, just to do some nice DC, okay? So that being said, actually don't have my glue gun connected, so that will take a few minutes. I'm just gonna hot glue this in place, and that's it. We have a car charger with a real DC voltage here. Thanks for watching. See you next time.